Okay, with the second recording for this chapter, chapter 13, partial differential equations. We're going to solve a question on second order partial differential equation. We're going to go with the famous example, which is called the wave equation or the vibrating string equation. I'm going to write the question now and we'll start solving. Partial square u over partial x squared is equal to c squared, which is just a constant.
Are you sharing your screen?
Sorry, didn't that appear? Sorry. Could you see my screen now?
Yes, thank you.
Okay. So the equation is partial square u over partial x squared equal to this constant c square multiplied with partial square u over partial t squared. Okay. This is called the wave equation or the vibrating string. And the boundary conditions are given in the following matter. It's given this way. It's given in a, you can say it's given in a diagram instead of just written numbers. You can extract the boundary conditions out of the drawing itself. Okay. Okay, see, this is the wave. This is just a string that's been held from, let's say, this side or any side, and it's vibrating, oscillating in this following diagram. You can say that the boundary conditions are the following here. U of 0, t is equal to 0. U of x and 0 is equal to 10x. Remember that we're going to use this at the end of the whole solution, which is b of 0. We're going to use it in Fourier series. And as for here, u of l t is equal to 0. U at infinity of t is equal also to 0. Okay, let's write the assumption. What's the assumption? Can anyone help me here? Do you know what's the assumption for this PDE? Remember what's the assumption? The function above, the variable of the function above, just write it in capital form or change it in any way, whatever, doesn't matter. Then the variables down here, also in capital. In some books, you can find them in this indication. I go with simplicity. I go with normal x with the normal t. It doesn't matter. It's just a variable that you made up. But go with something related to the first variables, okay? So I'll go with the capital X, capital T. Now you need to use this substitution. Substitute it here in the original equation. So this will give you partial square u over partial x squared. This means that we need to differentiate for the respective x twice. So this will give you x double prime t is equal to c squared, which was just a constant, doesn't change. And partial u squared over partial t squared means that we're going to differentiate the respective t twice. So it's going to be x t double prime. Okay. Now, as for our third or fourth step, we're going to divide by the assumption. Going to divide by the assumption. So this will give us x double prime over x c square t double prime over t. Okay? Now, these both equations, this and this, are both equal to another constant, which is maybe lambda or k, doesn't matter. Just use your own, it doesn't matter. Okay? Now you need to solve this equation individually. One's for respect of t, and the other is to the respect of x. So let's go with x double prime over x equals to lambda. And here c squared t double prime over t equals to lambda. Now to solve this, you need to multiply it with x, then subtract this to the other side with just the opposite sign. So x double prime will give you x double prime minus lambda x equal to 0. As for this, multiply with t over c square. Remember that you want to keep the double prime alone, okay? Always, for all cases. So this will give you, okay, so this will give you t double prime minus lambda over c square t equal to 0. Do you understand this step? Do you understand this step? Okay, I'll assume that you do. Okay. Now going to the cases, we are going to find the value of the function for 3 cases. Starting with case 1, lambda is equal to 0. Again, split your page into 2 because we're going to work on these 2 equations for can go for a few steps with the splitting the page into 2. So lambda is equal to 0. This will give you that x double prime is equal to 0. Since this is equal to 0, it can be cancelled, right? Now you need to integrate twice. X prime is equal to c1, x is equal to c1, x plus c2, okay? That's the solution for the x. As for t, the same thing goes here. Since lambda is equal to 0, this whole term will be cancelled. So t double prime is equal to 0, t prime is equal to c. So c1, c2, we have c3 here. And t is equal to c3 t plus c4. Okay, now we got the solution for the other variable. Now again, we need to multiply or use these both in the assumption. The assumption again is x times t. So what is the multiplication of this function with this function? Okay. So c1x plus c2 multiplied with c3 t plus c4. Now it's just a matter of distribution. c1x with c3t. Remember, any c1 multiplied with another c, 1 million, 100, whatever, it just give you another c or another constant. In this case, we're going to use, if there are 2 constants with the, you can say with the subscript. For simplicity, you can go with the alphabetic letters. So starting with letter A, going into whatever letters you're reaching, maybe to Z, whatever. Okay. Just remember this. So C1x multiplied with C3t, it's equal to AXT. C1x multiplied with C4, it's basically constant times a constant. So BX, that's it. Now, as for C2, it's going to be CT. Now, constant times another constant is just a constant, so it's D. So this is the first solution of the partial differential equation. Of course, we are not done, otherwise it won't be that easy. Okay, I'm just kidding. So this is the first solution. For the second solution, we're going to use lambda is equal to positive beta squared. This is case 2. Okay. Now we need to substitute the value of beta square back here. Since we have these. Okay, since we have these, going to use lambda is equal to positive beta square. This will give you x double prime minus, because the positive doesn't change, the minus beta square x is equal to 0, t double prime minus beta square of a c square, t is equal to 0. Now, by using the formula sheet or the cases that you memorize when you have this equation, it will give you the following solution. So x is equal to C1 e to the power beta x plus C2 e to the power negative beta x. You can also use my old method or my actual method that I posted in the first video, part 1, where I solved part 1 in 2 methods. And I used my method in these 2 methods, my method in this particular step, where I, instead of using x double prime, I used m square, and instead of using x, I used nothing, just a constant before it. So just go through with it. So if instead of using your formula sheet, or you forgot to write your formula sheet, or you don't understand what's written in the formula sheet, you can use my method. Anyway, this will give you this solution. As for t here, it will give you a similar solution. T is equal to C3 e to the power beta over CT plus C4 e to the power negative beta CT. This is the second solution. This is the second solution. Now, again, we need to multiply with the assumption. This function multiplied with this function or this equation will give you the following. So this, I'll change the pen for you to understand this better. This times this, a constant multiplied with a constant at the beginning first, will give you another constant. As for the x with the e, the number with the e, since we have the same base, which is e, the natural number e, we'll only have to put the base here and just add up the exponents. So beta x plus, that's a plus, beta over ct plus this multiply with this. Again, a constant multiply with a constant, same base, just find the summation of the exponents. So beta x minus beta over ct. Now, as for this term, C2 multiplied with C3, a constant multiplied with a constant, give you another constant. As for the natural number E, same base, just find the summation of the exponents. Beta x plus beta over ct plus, again, this with this. A constant multiply with a constant, d, same exponent. Find the summation of the exponents. Beta x minus beta over ct. Now this is the second solution of the PDE. Okay, we're not done yet. We need to find the third case or the third solution. Case 3, lambda is equal to negative beta square. I'm going to use the same again and again. Split your page into two. Always remember this step. Split the page into two. Prepare yourself that you're going to split your pages. Okay, so it's going to be easier for you to operate and easier for the instructor to correct your paper. So just substitute the value of beta square, negative beta square. Okay, now remember that we have a negative and a negative and a negative, so we need to go to change the signs. So this will give you x double prime plus beta square, x is equal to 0. As for this will give you t double prime plus beta square over c square t equal to 0. Now remember, since we have a positive here, and this is a second degree, these both will have the solution of sine and cosine, okay? Remember this, okay? I don't have another method to make you memorize it other than the differential equations, but you can, I don't know, rely on this. When you have this solution with a negative and the second order, remember negative, negative, and the second order, you need to go with the solution of E, the solution that has a C to the power E to the power exponent plus C to the power C times E to the power negative of the exponent, okay? This is the solution if you have a negative second order second order differential equation on each side. Okay, for each side, this will be the solution. Remember, negative and second order. Remember, second order. If it's a first order, no matter what the sign is negative or positive, you'll have the same solution just with the change of the exponents. Okay? So this will give you the following. Just please give me a minute. Okay. I just got a call. Okay. So yes, first order will give you this solution. Sorry, I said that late, but I just got it to remember to tell you another method or the another way of memorizing. See, I'm bad at memorizing, so I don't have that good methods, okay? So go with your own way of memorizing. Just please remember these and don't mess up in the exam, okay? Remember that if you're going to have a second order for both sides, you must have a linear solution, which is this. A solution that has a e in it, logarithmic solution or exponent solution, whatever it's called, exponential solution. And finally here we have a trigonometric solution that has a sine and a cosine. If you have a second order and the first order, then you will get a hell of a mix-up. Just try to solve as much as you can. Okay, here, x double prime plus beta square x equals to 0. This will give you that x is equal to c1 sine beta x plus c2 cosine beta x. Okay? As for this, t is equal to c3 sine beta over c t plus c4 cosine beta over c t. Okay, this is these are the solutions for each equation. Now, finally, the assumption, multiplying this function with this multiplied with this first will give you a sine beta x multiplied with sine beta over c. Now this again multiplied with this will give you b, not beta, b sine beta x cosine beta over c t. Now for this and this plus c cosine beta x sine beta over ct. Now the same with this, give you d cosine beta x multiplied with cosine beta over ct. Okay, this is the whole solution. This is solution number 3. Okay, sorry for the bad rectangle. It doesn't matter. Okay, this is the third solution. Okay. Now, finally, we need to use the boundary conditions. I believe that's your favorite step. Is it? Is there anyone in the meeting, or am I talking to myself? I think that I'm talking to myself. Okay. At least you have the recording. Okay, applying the BCs, the boundary conditions. Again, the boundary conditions are not something for you to made up. It's given here. Okay. Okay, this is T. These are your boundary conditions. Now you're going to use it on the first and second and third case. Remember, the solution is always with the case that has a sine and a cosine. And the solution is also for the case that has an L in its place, or L in its in its form. I'm not sure what it's called. So, okay. Now applying the BCs on case 1. Case 1. See, the trick is to know what cases you want to use. Maybe you're given like another 2 cases, okay? You can go and use them. Are you sure that you will know how to use them? You will always have the same 4 main cases. You might get more, you might get different ones in other equations, but you'll still get these 4 boundary conditions. Personally, I go with this and this. I don't know how to use this. To be honest, I'm being honest with you. I don't know how to use it. I don't want to know how to use it. I'm happy with these. As for this, always it's just for the Fourier series here. You're not going to play with it. Okay? Personally, I don't like to use this. You can use it if you want to. I don't want to. So going to case one, u of 0 t equal to, again, we are going to substitute the value of x where it's going to be 0. X is equal to 0 in this case. Okay? Now we have the solution of case one. Solution of case one, which is this. I'll send you the solution in a better and a tidier form. I think that you have it in the group. I already sent it before. So check it, please. So A times 0 t plus b of 0 plus c t plus d is equal to 0. This will be simplified since these are cancelled now. So you have ct plus d. Okay, does this make sense to you? Ct plus d is equal to 0. The only way for this is a linear equation. This is just a constant. Okay, this Ct is just an equation that has this form or this. See, it's just a linear one. Okay, as for d, it's just a constant. Can this be equal to this? The only way that both can be equal is only when c and d are equal to 0. When both of them are equal to 0. So c is equal to d is equal to 0. Okay, now this gives you the simplification that c and d are useless. So you need to rewrite this again in this following form: axt plus bx. Okay, this is your new ux of t, u of x and t. So this is the new u. Okay, new one. Now we're using the other boundary conditions. L of t, L. Well, L is just the length of the string. In some examples, maybe L will be given. L, maybe it's equal to 10, equal to 4, equal to 100, doesn't matter. In matter of solution, you will end up with the same thing. Okay? L here is just a constant, it's not a variable. Okay? Remember this, L is just a constant. It might be given. In some cases, you might get u of 3t. It's the same. If you substitute the value of 3 in anything, even when you reach to the solution of Fourier series where you have an L in it, eventually it will be cancelled out, so it doesn't matter. Remember this. Again, sorry, I got overexcited. I love this chapter. So A of L, do you have two pluses here? Plus B of L is equal to 0. Now solve this. The both L's can be cancelled, and you will end up with A of A t plus B equal to 0. Now you're having the same case here, and you cannot have a linear is the same time is equaling, or it's the same, or just a constant. Because you know, if you solve this, it will go to the other side, right? I see something stupid here. Okay, this is a t and this is a plus. Okay, it cannot be a is equal to at is equal to negative b, and you cannot have a ct is equal to negative d. The only cases that you can have them is when c and a, d and b are all equal to 0. All are the same. So when you have a, b, c, d are all equal to 0, this gives you that u, x, and t is equal to 0. So it doesn't make sense that you're working all this and then eventually will end up with a 0. This is unacceptable. So you reject this solution. Reject. Okay. Now going to case 2, where you will also reject the solution, but just you're pretending that you are making something new to the society, where you're not, of course, unfortunately. Me too. Anyway, so case 2, u of 0t. We'll have case 2 here in front of us for us to be capable of seeing what I'm doing. Okay, can someone start solving this with me instead of talking to myself? The both Mariam, Shahad, and Hana. I guess I'll be talking to myself again. Okay, that's unfortunate. So having the value of 0 give you ae to the power beta over ct. C because x is multiplied by x is 0 multiplied with beta, so it will be cancelled. Same thing here, same thing here, same thing there. So plus b to the power negative beta over ct plus ce to the power beta over ct plus de to the power negative beta or beta over ct. You can simplify this since we have the same, use different pens. So we're having the same e with its exponent, two and two constants. So just get common, what's called common number or common whatever, common anything. Okay, this will give you that a plus c are both common with beta over ct, and there's b plus d. It's also common with e to the power negative beta ct equal to 0. Now, saying that both are constants, change them to another a, b, c, d, e, and f. Okay, you can do this, you can just not do this, depends to you, but personally I would like to do this. So you get e beta over ct plus f e negative beta over ct is equal to 0. Now try solving this. Does this make any sense? Since we have positive and negative in the exponents. Try solving this in any way you like. Okay, does this make any sense? Can, let's say, 10 e to the power 4 be equal to negative, since we took this to the other side, negative maybe 5 e to the power negative 4? Does this make any sense? If you played with the constants, do you get any answer? No. But if you change the constants to 0, yes, it's equal 0 plus equal to 0. So this means that E and F, or E and F, which are also the values of B plus D and A plus C, are all equal to 0. This gives you that A equals C equals B equals D are all equal to 0. Maybe you not understand my assumption, but you can go and try to solve it as much as you like, and you will end up with this solution that A and C and B and D are all equal to 0. Now finally, with case 3, case 3, my least favorite case. We're going to have U at 0 and T. This will be equal. Now we'll start just substituting the values of 0 and the x's. Now just a quick reminder that sine 0 is equal to 0. So anything multiplied with the sine 0 is just 0. It will just cancel it out. As for sine, or not sine now, as for cosine 0, it will be equal to 1. So multiplying it with anything will just not change it, just will cancel the cosine 0 and give it the answer of 1. This will cancel the whole solution, or the whole constant multiplier, or the whole factor. So now here, sine 0, so, x is equal to 0, so here sine will be 0, and here 2, here we'll have a cosine 0, here we'll have a cosine 0. So this will tell you that this solution at first will be cancelled, not always, just at the first steps, it will be cancelled, right? Am I correct? I guess so, yes. Okay, so these will be cancelled. So now we'll just play with these. C sine beta over C plus D cosine beta over CT equal to 0. Can a sine term be equal to a cosine term with both having the same angle? Can both be equal? Even it's negative, positive, doesn't matter. Can both be equal? Can you try solving them? Can you do anything? You cannot. Regardless the factor that you're having, sine theta is not equal to negative cosine theta. Correct? Even with whatever factors you're having, change D and C as much as you want, and you will not end up with equality. So this gives you the indication that C and D are equal to 0. So basically these are useless. Okay, the last two terms are useless. Yes, the last two terms are useless. Now you just end up with U, X, and T. A sine beta X sine beta over C T. I'm forgetting the T. Okay. Plus plus B sine beta X cosine beta over C T. Okay, this is our new U. Okay, this is the new U, the new one. After canceling out C and D, the useless numbers. Now this needs another boundary condition. You have 0t, or the same boundary condition actually. No, sorry. Yes, that's need a second boundary condition, sorry. U of L and T. I believe that I'm talking to myself, so I don't know if you're understanding this method, but I will do another tutorial right after this one where I'm explaining the second method. Remember, I prefer you using this method because the doctor won't be mad at both of us and he will give you a good mark. If you use my method, he might get angry and he want to kill me. I don't want that, okay? So try to use this method, try to understand this method. Then you can go to mine if you do not understand this method. So this is just a messed up beta here. Okay. Now I'm substituting the values of L. This will give you A sine. See, I suggest an alteration instead of using it in the second step. I suggest using it here. Since you have a sine beta x and another sine beta x, you can take it as a common factor. So no, there's no a here. Sine beta x, common factor. With a bracket, there's a sine beta over c, beta over ct, plus b cosine beta over ct. Okay, this is the new u. So here, substituting the value of L in the X, so we'll get sine beta L, open the bracket. We'll get A sine beta over CT plus B cosine beta over CT is equal to 0. Now, by using basic algebra, you can see here that we're having two solutions. The first solution where we cancel this and work on this. The second solution where we cancel this and work on this. Now just try to, just for fun, to use this solution. Actually, that's not just for fun, just for you to understand. There's no fun in this. There's something stupid here. Just give me a minute to charge my laptop. Okay. For you to understand now, we splitted the solution into two equal to 0. Now we can see that you cannot solve this and you don't care about this. So just reject this part. I'm going to this where you're going to solve this and reject this. Sine beta L is equal to 0. Now for sine theta to be equal to 0, theta must be equal to n pi, where n is just a counter. So we're going to do the same here for sine beta L. For beta L to be equal, since beta L is just theta here, or just the angle, beta L must be equal to n pi. Now change to the respective beta, you'll get n pi over L. Now this is the value of beta. Eventually, we will end up with Fourier series. Fourier series is 2 over L, 0 to L, where I just told you before that the boundary condition does not matter about, where is the boundary condition that I was talking about? Yes, about the L thing. You can have any number, any constant given. Eventually, it will be cancelled out. So it doesn't matter. Do not afraid if you got u of 3t. Okay, it's the same thing. Just substitute anything, it will get the same answer. Okay, now we're going to use this, which is 10x is equal to 10x. So this is actually the value of bn, 2 over L, b of 0, which is 10x sine beta x, or the new value of beta, which is n pi over L x dx. Now, this is your Fourier series. Use now 10x. I don't want to rewrite it. I'm just lazy, but you do that because you should not be lazy during the exam. Okay, So to solve this, you can take 10 as a take it out because it's since a constant if you want to, or keep it. I like to take it out. 0 to L sine n pi over Lx dx. Now, actually, there is an x here. I forgot it. Don't forget it. Now, this can be solved using integration by parts or tabular integration. I like to use tabular. I don't like to use integration by parts. This is a personal preference. You can use whatever you want. So x, starting with this function to be differentiated, and this function to be integrated. Okay? X, 1, 0. Now, as per the integration, sine n y over Lx, the integration of sine is negative cosine. Correct? Yes, negative, the reciprocal of the factor of x. So L n pi cosine n pi over Lx. As for this, the integration of cosine is just actually negative cosine, just negative sine. Correct? Can someone review this for me because I suck at this. So L over n pi square cosine n pi over Lx. Can someone check this for me? Is my integrations correct? I got a bit lost. Please, guys, am I talking to myself? Hello. There's no one here. لا حياة لمن تنادي. Okay. That's disappointing. This will give you the value of L and pi x cosine n pi over Lx. There's a negative here. 20L. Okay. Minus, positive minus here. L over n pi square. This is a sine. I write it mistakenly. Sine. Okay. N pi over Lx. 0 to L. Now, knowing from Fourier series that the sign can be cancelled, if you substitute L and 0, it can be cancelled. So this will give you following 20 over L, negative L over n pi x cosine n pi over Lx, 0 to L. Now take this outside and you will get 20 over n pi negative x cosine n pi over Lx, 0 to L. Now substitute the value of L and 0, the interval of the integration, and you will get 20 n pi L cosine n pi minus minus 0. Is that correct? Yes, it is. This will give you finally negative 20L over n pi. Cosine n pi can be changed to negative 1 to the power n. You can keep it and use the other method, doesn't matter. I personally like this. Now you can test the odd and even values and you will get both different values. This gives you the indication to keep this as it is in the Fourier series. Try solving it yourself. Please try solving this question yourself. I got this question in my midterm. Remember this. Remember what I said. I got this question in my midterm. 0 to infinity negative 20 L over n pi. I think there's a mistake with the signs. I don't think that we should end up with a negative, but please review it yourself. M sine n pi over L x. Okay, that's the solution of u or u, x, and t. Okay, that's the full solution of this problem. Okay, you can see that why I wanted to solve this in a different tutorial. Okay, now this is by solving using my method. Sorry, not my method, the doctor's method, or the one that I suggest for you to use. Now we can leave the tutorial or leave the session if you want to. Now I'll start solving using the other method, my method, for the people who do not understand this. Can you go back? I can't open my mic. Sorry, I didn't see that. Where do you want me to go back? Mariam, to the integration part, but I got it. Yeah, okay. So, okay, you can leave the session if you want to, because I just explained what would you encounter in your chapter. We got three, remember, we got three types of questions. First order with first order. This is the easiest one. The second type of question, which is second with first order. This is the most common one, which is widely known as the heat equation, which is the widely known example, not the widely only example. The probably you'll get this actually in the exam. The heat transfer equation. The third example or the third type, which is second order with second order, which we just solved. And it will take around 5 pages of solving, which is best known example is called the wave equation. Okay, the wave equation is the vibrating string equation. If you don't understand this method, you can wait for the second tutorial, which is in a few minutes, where I will explain the second method and I will start from the beginning, finishing with Fourier series. Second method. We'll stop the recording, separate these, stopping the recording.